So for our chapter 7 mini lecture, I wanted to take a closer look at one of the sections about sleep and dreams. It's pretty interesting to me because I've always been curious myself about it, and I feel like it was very well explained in this chapter. It does include a lot of vocabulary, so I'll be going through that a lot, but that explains most of the chapter, most of this section of the chapter. So there are a lot of ancient texts about sleep and dreams, and if you look in the Bible or the Hebrew Bible, there's a lot of prophetic dreams mentioned. So for one example, which is retold in the Quran, it says the Egyptian pharaoh dreamed about the 7 fat cows being eaten by 7 skinny cows. And then there's also a poem about Gilgamesh where he has a series of dreams in which his comrade Enkidu interprets as foretelling the future. So there's a lot of other examples with the pharaoh, actually. For example, the pharaoh promoting Joseph when he had a dream about famine. A lot of Hindu scriptures. Essentially, there's a lot of different ancient texts about sleep and dreams and all that. So essentially, there's a biological rhythm that enforces a sleep and wake cycle. So vocabulary, there's a biological clock, which is a biological mechanism that keeps track of time in our bodies. The circadian rhythm is an animal's active rest cycle with a duration of about 1 day. Suprachiasmatic nucleus, or SCN, is a small region of the hypothalamus that controls circadian rhythm. And then jet lag is just the disruption of circadian rhythms caused by rapid travel across time zones. So if you're going to travel from the East Coast to the West Coast, you're going back in time essentially, and gaining more sleep time, I guess. And then if you're going to the East or like say from New York to Europe, you're going to lose time because you're traveling ahead in time. So your biological clock wants to keep you on a constant cycle. It's always trying to keep you regular. And that's important to note because it's adaptive to predict when the sun will rise and set. And honestly, all animals have a built-in biological clock. So there's a lot of mention in this section of the chapter about doing experiments and bringing animals in, such as hamsters, to kind of figure out more about the biological clock. And then the biological clock is underlying circadian rhythms of activity and might have been in almost any organ, but the clock is actually in the brain, or the SCN, also known as the suprachiasmatic nucleus. So that's actually in the brain. The clock is in the brain, but it's thought to be in some of the organs, but it's actually not, which is very interesting. So there are 2 different categories of sleep, and we'll go into more of those later, but this is a lot of vocabulary here, so I'm just going to go through it briefly. So we already talked about an electroencephalogram in a couple chapters back, or an EEG, and it's basically a recording of fluctuating potentials taking place in the brain, and it's made by an electroencephalograph. A desynchronized EEG is also called beta activity, and is a pattern of EEG activity comprising a mix of many different high frequencies with no dominant frequency and with a low amplitude. An alpha rhythm is brain waves of 8 to 12 Hz that occur during relaxed wakefulness. So there are many different stages of sleep, and I'm just going to go through them briefly. So the first stage of sleep is stage 1 sleep, and it's the initial stage in which the EEG shows small irregular waves and characteristic sharp waves called vertex spikes. Sleep spindles are a train of spikes in the EEG. K complexes are large single spikes in the EEG. And then stage 2 sleep is a stage of sleep that is defined by sleep spindles and K complexes, which I just talked about. And then stage 3 sleep is the stage of sleep that is defined by the presence of large amplitude slow waves. So delta waves are large amplitude brain waves of 1 Hz, characteristics of stage 3 sleep. And then slow wave sleep, which is SWS, is a sleep that is defined by the presence of slow wave EEG activity, or delta waves. And then we're going to talk about now the 2 different types of sleep. So rapid eye movement sleep, which is REM sleep, is also called paradoxical sleep. And it's the stage of sleep characterized by desynchronized EEG, flaccid muscles, and rapid eye movements. And then the other type of sleep is non-REM or NREM sleep, which is sleep stages 1, 2, and 3, which we talked about previously. Manifest content is, according to Dr. Freud, what a dream seems to depict, kind of. And then latent content, according to Freud, is the real wishes that underlie a dream. Activation synthesis is a theory that dreams result when the mind stitches together a narrative from images and sensations that were generated by random neural activity. So this is interesting. I'm just going to go to it real quick. So the theory, basically, the theory posits that our experiences in REM sleep are the more or less random result of which neurons happen to get activated. So our brain then strings together these disparate elements into a more or less coherent story or a narrative. That's why you have very vivid dreams sometimes. So imagine a big like roller cage or type of things used for like lotteries or bingo games kind of, and it's filled with a million different possible things we might see or hear or feel in our dreams, but different bits are drawn out at random, and with each new random experience we try to piece together a story that fits the experience. So that's kind of what an example the textbook gave that I thought was pretty interesting. So in some ways we try to make this narrative from bits of random experiences, and we try to make it an extension of what we discussed in the first section of this chapter. So one part of my brain weighs many different factors to reach a decision about what to do next. Only later does the conscious self become aware of what the decision is. So that's interesting as well. So essentially the summary of this subsection, there are two types of sleep, REM versus non-REM. And then the last subsection of this kind of bigger section is about animals and if animals dream. So the subcutaneous is a region in the brainstem that inhibits motor neurons during REM sleep. And then REM behavior disorder, or RBD, is a syndrome primarily found in middle-aged men that involves movements during REM sleep that seem to correspond to movements taking place in the current dream. So in these middle-aged men, sometimes they will flail about in their sleep or kind of have a little bit of aggressive behavior sometimes, and that's REM behavior disorder. It's kind of unknown why, but men often dream about fighting or running away from some foe, and that's kind of the main example of REM behavior disorder. It can be controlled by several drugs, and they inhibit anxiety as well. So examining sleep in animals is important because it shows how crucial sleep is universally. But because vivid dreams come about in REM sleep and other mammals seem to have REM sleep, that's the big question. So do other mammals have vivid dreams? So that's something interesting as well. And there's a bunch of evidence behind some studies in this section about cats and postural cues to sleep states. So in this kind of visual, there's two kittens, and one must be in SWS because the body did not limp, as it would be if it was in REM sleep like the other kitten is. So it's just very interesting to notice the animal portion of this section as well. And that's it for Chapter 7 mini lecture.